In this video, we're going to find the derivative of a function using the fundamental theorem of calculus. Given f of x is equal to integral lower limit x squared to upper limit x cubed e to the minus t squared dt, we want to find the derivative of this function. So we're going to apply the fundamental theorem of calculus, but we're also going to apply the chain rule because the upper and lower limit are both functions of x. That is, x squared and x cubed are both functions of x. The formula we're going to apply is d dx of the integral from c to g of x f of t dt is equal to f of g of x times g prime of x. Now, before we can apply this formula, we need to split up the integral so we can apply this rule. So let's draw a line. The lower limit is x squared. The upper limit is x cubed. I'm going to choose any number in between, doesn't matter at all. So I'll just choose 0 for convenience. So what we're going to do is split up the integral. We're going to go from x squared to 0, e to the minus t squared dt, plus integral from 0 to x cubed, e to the minus t squared dt. All right, let's solve this. So what we have is integral x squared to x cubed, e to the minus t squared dt. That's split up, x squared to 0, e to the minus t squared dt, plus the integral from 0 to x cubed, e to the minus t squared dt. Now, the lower limit here, you will notice, is x squared, and we need to bring that and make that the upper limit so that we can apply the fundamental theorem of calculus. So we have to interchange the limits of integration, and we need to put a negative in the front. So that's minus integral from 0 to x squared, e to the minus t squared dt, plus integral from 0 to x cubed, e to the minus t squared dt. And let's write the left-hand side. That's x squared to x cubed, e to the minus t squared dt. The next step is to differentiate both sides of the equation with respect to x. So take the derivative of the left-hand side. That's d dx of x squared to x cubed, e to the minus t squared dt. That's equal to minus d dx from 0 to x squared, e to the minus t squared dt, plus d dx of the integral 0 to x cubed, e to the minus t squared dt. Now, when we differentiate this expression here, the derivative cancels the integral, so we get minus e to the minus x squared all squared, substituting x squared for t, and multiplied by the derivative of x squared. So that's going to give us x squared prime plus e to the minus x cubed all squared, and multiplied by the derivative of the upper limit, x cubed prime. Now let's carry out the derivatives. That's minus e to the minus x squared squared, that's x to the fourth, times derivative of x squared using the power rule, that is 2x, plus e to the minus x cubed squared, that's x to the 6. Apply the power rule, differentiate x cubed, that is 3x squared. Let's simplify this a little bit, and we will get minus 2x e to the minus x to the fourth plus 3x squared e to the minus x to the 6. There it is. All right, let's look at another question. Given capital F of x is equal to integral from 0 to x, x t cubed sine t dt, find the derivative. Now, the difficulty with this question is that we have two variables in the integrand. We have both t and x. Since the integration is with respect to t, that means that x acts as a constant, and we can bring it outside the integral. So let's do that first. F of x is equal to x, integral from 0 to x, t cubed sine t dt. Now you will notice that we have a product of two functions that involve x. We have x times this integral that involves x. That means we have to apply the product rule. Alright, let's apply the product rule. F prime of x will be the derivative of x, d dx of x, times the integral from 0 to x, t cubed sine t dt, plus keep x the same and differentiate the integral expression, that's d dx, 0 to x, t cubed sine t dt. Now a derivative of x is just going to be 1 times the integral from 0 to x, t cubed sine t dt, plus x times, now we have to apply the fundamental theorem of calculus. So what we're going to do is the x is going to, x will get plugged into t, and what we get is x cubed sine x. Let me rewrite this, make it look nicer. Sine t dt here. Alright, let's simplify this. What we get is integral from 0 to x, t cubed sine t dt, plus x times x cubed is going to give us x to the fourth. X to the fourth sine x. This is the answer. That is the derivative of capital F of x. Alright, thanks.